Hello, so in today's video, we're going to look at the next topic in the A-level syllabus, and that's rationalizing the denominator. So this is kind of a continuation of yesterday's video on the laws of surds. So rationalizing the denominator is essentially where we've got a fraction like this. Say we've got a fraction like this here. What we notice here is we've got a denominator, and we're going to assume that this denominator is irrational because of this square root of f there. We're just going to assume that this square root of f is an irrational number. I mean, in theory, the f could be the number 4 in theory, and the square root of 4 is 2, which is a rational number. So in theory, it could be rational, but let's just assume that this here is irrational. So let's just assume the root f is irrational, and therefore this entire denominator is irrational. So the key thing that we want to do, the objective, is can we make the denominator a rational number without actually changing this fraction itself? So we want to literally rationalize the denominator of this fraction. And the key thing that I've just wrote up here is that we're going to assume that A, B, D, and E are rational numbers. So this is a rational, that's a rational, that's a rational, that's a rational. We're just going to assume that C and F are greater numbers than 0. Again, that's just because when you square root a negative number, you get an imaginary number rather than a real number. And we don't want to be dealing with non-real numbers. We want to be dealing with real numbers in this syllabus. So the key point is, can we get this denominator to be rational without actually changing this fraction? So we don't want to change the fraction. We've got to keep the fraction the same. How could we do this? Well, we can use a little trick on this denominator here. So I've just labeled this this slide trick. So we're going to do this trick where we multiply this d plus e root f by d minus e root f. Okay, so why do we do this? So if we just expand the brackets, we get d squared there, we get minus d e root f there, we get plus d e root f there, and we get negative e squared f there, and that's just because e times e is e squared. We got the minus sign there, and root f times root f, as we know, is just the number f. So that's why we get that. And what do we notice about these middle two terms here? Well, they just cancel out. So now we've got rid of this irrational irrational root f, and we're just left with d squared minus e squared f. And now this is a rational number. Okay, so we've got this trick that we can use to kind of rationalize this number, but obviously we can't just multiply the denominator by that number because then the fraction changes. So we have to multiply the numerator by that number as well, because this number here divided by itself is just the number 1. So let's write this out in a more sophisticated fashion. So we've got this number a plus b root c divided by d plus e root f. We don't want to change the fraction. We've got to keep this fraction the same. So the trick is to times it by the number 1. But how could we rewrite the number 1? Well, the number 1 is just the same as this. It's just the same as d minus e root f divided by d minus e root f, because a number divided by itself is the number 1. Okay, so now we know from the trick on the previous slide here, when we multiply this d plus e root f by d minus e root f, we get a rational number. So we're going to rationalize the denominator just by multiplying this and this. So we know that on our bottom, we get this d squared minus e squared f. That's now a rational number. And then we can just expand the brackets on the top here. So a plus b root c times d minus e root f. I can't be bothered really, to be honest, to expand the brackets here, just because it's a bit tedious, but in an exam or in a homework question sheet, you would obviously expand the brackets and simplify as far as you can basically with that. But now we've rationalized the denominator. So this denominator here is now rational. So denominator is now rational. So the key thing here when you rationalize the denominator is you want to multiply by your denominator, but you just want to change the sign in the middle. And by changing the sign in the middle, this kind of process happens here, where the irrational roots just cancel each other out because you've added this minus sign here when you took the product of that number and that number. So that's the key trick to do, and that will always get you a rational denominator. So yeah, that's today's video concluded.